Welcome to the lab session of today. We're going to be looking at project 4. So for project 4, we are going to be building a simple burglar alarm system with LED indicator. Okay, so now how the circuit operates normally in the physical world. If you have a burglary detective system, it's going to sound an alarm whenever there is an intruder. Okay, so for you to be able to control intruders, you could install these kind of circuits that has the ability to sound an alarm when there is an intruder, okay, a suspected burglary into such environment. So we'll look at what the circuit entails, the components required for this building. So if you go to your electronic kits manual on page 16, you'll see how the schematic on the breadboard, how it is being designed. And then if you just scroll down a bit to the next page, that's page 17, you'll see the circuit diagram, and then it also outlines the components that we're going to be using for building a circuit. So we're going to be needing a 9 volts DC voltage supply, so that's my 9 volts battery, and then we need 1 kilo ohms resistor. 1 kilo ohm resistor. So we're going to be looking at for brown, black, red. Okay, basically brown, black, red. Okay, that's it here. Brown, black, and red. If you look at it, yeah, although it has 4 colors. The fourth color, which is gold, is the tolerance. So we don't need tolerance for reading the value of the components. So to get the rated value of the resistor, you just need the first 3 colors. So we'll need basically brown, black, and red for us to know the rating. So this is 1 kilo ohm, so you need just one of that. So of course you will need the breadboard where you're going to mount all your components. Okay, so I get that out. And then you will need 100 kilo ohms resistor as well. So you're going to be looking at for brown, black, yellow. Those are the basic 3 colors you want to be looking at to get the resistor. So yep, that's it here. So I have brown, black, yellow. So you need just one of that as well. Okay, like I said, few components, few components. Of course, I will need the battery cap to help me do the work. And then the next thing is you need LED. So red LED, we have red, we have green as well. So you make a choice. But the manual said you should use red LED. So but we have green as well. So I'm going to take red this time around. And then we need a transistor. Just the same transistor we use in building project 3. So it's BC547. It's NPN transistor BC547. So you've got a couple of them in your project kit. So just cut out one and then use. So we need just one of that. And then the next thing is the booster. We have a booster. Now the booster, it's a component that has the ability to sound an alarm when it's being powered. So once you connect the terminals to a DC voltage, the buzzer will sound. a very unique alarm. So if you look at the terminals, they are colored. That means they are polarized. So the red is for the positive supply. The black goes to the ground. So you need to keep this convention. The red goes to the positive line, while the black is connected to ground. Well, we will look at how it is connected in the circuit. The circuit diagram will actually tell you where the black goes to and where the red goes to. But by convention, black goes to ground and red goes to supply. Okay, and that goes with it that. And then finally, you have a 0.5 half meter length supply wire. If you look at your project kits, you're going to see one black cable, a wire that is folded, is as long as half meters. So that's why they said 0.5. So it's very long, half meters. So that's it for me. So I need it. So basically, I've got my components all set for project 4. So we will go to build now. So these are all my components here, and that's all I need for the burglary alarm system. It's just a demonstration, okay? All right, so let's go on to build now. So that's my breadboard. Like I said, you don't have to be stereotyped in your design. You can build from anywhere. You can start building from anywhere. Okay, you can start building from anywhere. So this is my transistor. Okay, and if you look at it very well, you'll see the 3 lines, the 3 terminals, 3 legs. The first one on my right is the emitter. Then the terminal in the middle is the base, and then the third terminal to my left hand side is the collector. So the emitter is connected to ground. So I'm going to specify my ground terminal. I'm going to use the first line as my supply, as my positive supply, and then the second line will be my ground. So just to do it that way, you see, I told you can be very dynamic in your design. So I want my transistor to be connected just this way. Okay, yep. So I will need some wire to help me connect. So I go back to my then I'll get some wire. So we have some wire here, so you can pick some wire. That's so I pick some. Right, so I'll need some wire. So I'm connecting the ground, that to ground, so that goes to ground. Okay, for me. Okay, so I've connected the emitter to ground. Then I have the base. So we're going to start connecting now. The bow surface, I need to connect my bow surface. The black of the bow is connected to the collector of my transistor. So the collector is this one here. The third line is the collector. Okay, here. So that is the collector, and then that's the base, and then the first there is the emitter. So I'm going to connect this to the collector. So anywhere is the collector, and then the second line from the circuit diagram goes to the supply. So I said the first line is my supply, so that's what I'm going to do. So I've connected to the collector and then the supply. Okay, so that's my buzzer connected. So let me just keep it well. Okay, yep. So the next thing I'm going to do is to connect the LED. Now I have my LED here, so I just need a red, and I need just one. So already you know the terminals for the LED, the long and the short. The long is a positive, the short is a negative, and then the long is connected to the supply line. Okay, and that's my supply line, so I put it there anywhere, and then I take it to any part of my circuit. So just put it, that's my LED connected. Then the LED has connected in series with a 1 kilo ohm resistor. A 1 kilo ohm resistor. If you look for the colors brown, black, and red, you get 1 kilo ohm resistor, and that's going to limit the current flowing through the LED to ensure the LED is working within its safe operational limits. Okay, so it's going to be working within its operational limits. So with 1K, we're going to reduce the amount of current that's flowing through the LED for safe operation. So that's connected to the LED and then to the collector of the transistor. So that's the collector here again, and then it goes to the LED. So that's fine, connecting to the collector and then to the LED. The next thing to connect is the base resistor. The base resistor is 100 kilo ohms. So you're going to be looking at for brown, black, and yellow color resistor. So these are the colors you'll be looking at for brown, black, and yellow. Okay, so that connects to the base of the transistor, and then to the supply line. So the base is in the middle, so I just put that in the middle here. That's the middle leg, and then it goes to the supply line. So that's the supply line for me, and then the other one goes to the middle leg. Okay, so it's well connected, everything well connected. Okay, then the last thing is to connect the wire here. This is the half meter supply wire. Now this is going to be serving as our window or the door. So, and the door is going to be securely closed to avoid unauthorized access. So for you to close that, you need to connect it just the way it is in the circuit. So it's connected between the base and ground. So you connect to the base of the transistor and ground. So that's the base here, that's the baseline. So I can put it here, and then I said the first line is going to be my ground, so I put it anywhere here. The second line, sorry, is my ground. So that's it. So that's me, and that's the circuit complete. So everything is now ready. So all we need to do is to try to on the circuit. I can try to make my door look very nice. So if you want to do that, you can just coil it a little bit. So that goes to the base, between the base and so that's my door or window closed. Try to keep my I don't need this anymore. I've finished using it. So I'm fine with that. Okay, so that's the basic design here. So the next thing is to power the circuits. Now Normally, if you don't have any intruder, there shouldn't be any alarm in the circuit. Okay, so it shouldn't sound any false alarm. So the circuit is well designed not to produce any false alarm when it is powered, because we are not expecting any intruder. It should sound an alarm when there is a burglary action. So I'm going to power the circuit, and then we will not expect any alarm sound. I'm going to power my circuit. Then you see everywhere is quiet because everything is perfectly connected, safely connected. So that's the power line. I think I need to just keep it in a way. Okay, yep, so it's fine this way. So that's everything ready. So we want to test our circuit now. It's finished, it's complete, ready for testing. Okay, so the circuit is expected to sound alarm whenever there is an unauthorized access into the building, into the safe, whatever you're protecting. Okay, it should sound an alarm to alert the people in the environment, to alert security that there is an intruder in the environment. There is a burglary action ongoing, and so security can be alerted. Okay, so for you to do that, you need to interrupt. You need to break into the building through the window or through the door. And this black wire represents the window or the door. And to do that, you must open the window or the door. To open means interrupt that wire. So if I take one of the terminals out from its position, it means I've broken into the building. That means a burglary action. That means I am intruding into the environment, and the circuit should automatically raise an alarm and indicate with an LED. The LED should come up to show that, that the circuit is functioning and operating because there is a burglary action. So let's see what happens. So I'm going to take off that because I'm trying to break into the building without permission. Okay, so that's it. And then security has been alerted, and then they try to stop who is trying to break into the building, into the safe, who is the unauthorized intruder. They try to quickly arrest the situation, and after they arrest the situation, they try to restore the system back to its normal operation by taking this back. So you close the window or you close the door again. So take it back to ground, and then that's it. So it's very simple circuits. I hope you enjoy building this. Okay, so have fun. Thank you.